Hi, in today's lesson, we're going to practice writing those explicit and recursive geometric formulas. We're going to focus more on getting that explicit formula than the recursive. But let's look at this very first problem. It says to write both a recursive and an explicit definition or formula for the following sequence. So it goes 2, 4, 8, 16, and so on. So this is a geometric formula. And we can see that we are multiplying by 2 each time. So let's start off with, the recursive formula. So my recursive formula, if I write it in function notation, is that f of n is equal to my previous term, which is f of n minus 1, times 2, where f of 1 is equal to 2, okay? Or if I use subscript notation, that would be a sub n is equal to a sub n minus 1 times 2, where a sub 1 is equal to 2. Okay, that's the recursive. The explicit formula is going to be a little bit more challenging, right? So the explicit formula is going to be the one that looks more similar to that exponential function rule. All right, so if you're having trouble coming up with how we're going to write that explicit rule, look right here. It's that a sub n is equal to a sub 1 times r to the n minus 1 power. So if I write this in function notation, that'd be f of n is equal to the first term, f of 1, my first term in this case is 2, so this one gets a little bit confusing, times r, your common ratio. Well, your common ratio, what are we multiplying by each time? We're also multiplying by 2 to the n minus 1 power. If I write that using that subscript notation, it'd be a sub n equals 2 times 2 to the n minus 1 power, okay? So the general notation. In order for you to use this rule, you have to be given the first term. You have to know what the first term is, and you have to know your common ratio. That's that r. Okay? So let's try one of these. So here's our sequence: 4, 12, 36, 108, 324, and so on. So we're going to write an explicit formula for this sequence. But before we write that explicit formula, what is our common ratio? So it looks like we're multiplying by 3 each time. So that r is 3. So following our formula, so we'll use subscript notation. A sub n is equal to your first term, which is 4, times your common ratio that goes in parentheses, which is a 3, to the n minus 1 power. So it'd be 4 times 3 to the n minus 1 power. Now we can use that explicit formula to come up with any particular term in the sequence. So in this case, part C is asking what's the 10th term? So what is a sub 10? So it'd be 4 times 3 to the 10 minus 1 power, or 4 times 3 to the 9th power. So if you're typing this into your calculator, the first thing you need to do is figure out what is 3 to the 9th power. So 3 to the 9th power is going to be 19,683. And then we're going to multiply that by 4. 4 times 19,683. Which would be, let me erase that comma. I didn't do a very good job there. 78,732. That is a very large number. Okay, now it is your turn. So you're going to do number 2 and 3 and 4. 4 has 4 parts to it. So go ahead, pause this video, finish the worksheet, and then we'll come back and check. Welcome back. All right, now it's time for you to check over your answers. So first you'll see problem 2. So pause the video, make any necessary corrections for number 2. Okay, here we have problem 3 and then 4A. Go ahead and pause the video, make any necessary corrections. Okay, and then you can see number 5, parts B, C, and D. Go ahead and pause the video and make those corrections. Great. Hopefully you guys did well with this. Again, if you have any questions, please see me or your teacher. And go ahead, let's submit this assignment and you're ready to do your independent practice for today. Good luck.